This is Fragmented, an Android developer podcast where we talk about building good software and becoming better human beings by becoming better Android developers. We're trying something a little different this week. I'll let Donn take it from here.
Hey, welcome to the podcast. Kaushik and I have discussed and had a lot of feedback from a lot of listeners in regards to the show in general, and the consensus is that everybody wants to hear a little bit more from the Fragmented podcast. Truth be told, though, we put a lot of work into developing the Fragmented podcast. We find the right people to interview. We do a lot of research. There's a lot of back-end work that goes on behind the scenes for us to bring you the episodes that we do bring you. So it does take us a lot of time. This is the reason why we haven't been able to bring you weekly episodes. But we'd like to try to change that. And one way that we want to change that is by introducing something called the Fragmented Podcast Fragments. And what these are going to be are short little segments from anywhere from 7 to maybe a little over 20 minutes long, where we talk about a particular topic that is very important to, could be software engineering, could be computer science, maybe something related to startups, maybe something that you're going to deal with when you're developing mobile apps inside of Android development, and so forth. And so today is the first Fragment episode that we're going to have. And today I'm going to talk a little bit about continuous integration and collective code ownership. So let's just hop right into it. First question is, what is continuous integration? I think the best definition is from the guys over at Thoughtworks. And they provided it online. If you can go to thoughtworks.com/continuous-integration, and it reads, continuous integration, CI, is a development practice that requires developers to integrate code into a shared repository several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. By integrating regularly, you can detect errors quickly and locate them more easily. Now, that's a lot of lingo it's throwing around here. And basically what it means is we put our source code in some type of source control system that's shared. Let's just use GitHub as the example. You could use Bitbucket, whatever. Well, we're going to have a team of people, and everyone's going to talk to this one shared repository in GitHub. And then we're going to have another server that sits off to the side that no one programs on. It kind of just sits there and runs and watches that repository. And as soon as check-ins are made, it says, hey, there's some new code up there, and it pulls the code down automatically, and then it runs the build script to make sure that the application compiles, that maybe all the tests pass and everything. And if something goes wrong, it kind of notifies everybody. And when it succeeds next, it notifies everybody again. And it's kind of like a source of truth, essentially, but it enables us to act more cohesively as a team. Now, there are some higher level concepts about this, like the practice of doing it, how to do it, team responsibilities when you work inside of a team. And we're going to talk about those right now. I think the first one is really how to do it. And I just touched on that generally, but I'm going to hop into kind of a little bulleted list here. And the first one is developers are going to check out code into their private workspaces. So your desktop, your laptop, whatever. You're going to make some changes, hack away on it. You're going to commit your code, and you're going to eventually push it up to the main repository. Again, let's say GitHub. That server was going to look at that repository, check out that code, build it, whatever. It's also going to actually release any deployable artifacts. And what that means is an artifact in a build environment is an APK, which is the Android output when you build an application. It may also assign a build label to that particular build. So it says, hey, it may tag it inside of Git saying this was build number 700, and it tags it. And if the build fails, what it will do is notify and alert the people of the team, basically saying, hey, this commit broke the build, and at that point, the team needs to fix the build at the earliest opportunity. And then what happens is this happens throughout the day. So if you have many people sending commits up there, your builds are maybe crunching away all day. As commits come in, it's just firing off another build and building and building and building, and just making sure everything is okay. Now, again, the main practice around this is that we want to make sure that there is a single source repository. So that's rule number one. We need to have some place where we all can access the code. It shouldn't be on some zip drive or sitting on some network somewhere. We need some type of version control system. That's rule number one. Make sure you got one of those. Second thing is we need to make sure we automate it. So that means it has to happen without no intervention. I just need to be able to check the code in, and then all of a sudden the build server fires off and does it. You need to make sure that you're running your tests on it. That's a big one there, is your build script just needs to fire off the tests. You might need an emulator if you're doing Espresso or UI Automator test or something like that. You may need different types of builds as well, and we'll talk about that in a second. You want to test in a clone of the production environment. So if you're using perhaps a web service and your tests are going to hit this web endpoint because it's a full integration test, you want to be trying to be as close as you can to a production environment. Fault tolerance, all that kind of stuff said nowadays. It's kind of hard to set up an exact production environment, but you can. Example, like if you use Docker or something like that for your endpoints, you might be able to clone that Docker instance instead of firing it up on an AWS extra large instance, you may fire it up on a small or a micro, save yourself some money, but it's basically the same setup there, so you can make sure things are working accordingly. We want to make sure we keep the build fast. This is key here. So there's two different things that we need to think about here. When you have a build and you have tests, unit tests are unit tests. They're small units that you can test very, very fast. You should be able to execute hundreds, if not thousands of them within a second or two. Many languages do this. Now, Android is a different beast because you have Espresso and UI Automator. These are integration functional tests that are running from top down, executing the actual code and clicking buttons and so forth. In order to keep the build fast, we want to use unit tests. And so this is where I said we may need two different builds. One's going to be your quick test. This is where you keep the builds fast. When I check in a commit, the build finishes in a couple of minutes, maybe up to 10 minutes at max. Even that's a little risky, but it happens sometimes. And then you have your integration tests. And I've seen some of these take as long as 4 or 5 hours because there's hundreds or if not thousands of these integration tests that run. And that may run daily. Every night it may run and then send a report out saying, here's the test that broke. Or if it maybe only takes half an hour to run, you may run it once an hour. It's kind of up to you to see how long those things break. But you want to keep the one that's keeping everybody in the loop always over and over. That one needs to be fast. Next thing is we need to make sure it's easy for anyone to get that artifact. I should be able to have my boss log in and download the latest APK. So he says, hey, what's the latest code drop look like? He says, hey, it's building on the build server. You can get it in about 5 minutes. And as soon as it's done, he can just go to a web page using whatever build server you're using, download the artifact and use it. Furthermore, we can get into automating deployment, which we'll talk about here in a minute. Now, there are some responsibilities if you're on a team that you need to kind of adhere to, and it's a good thing to follow also if you are working by yourself. Number one is check in frequently. So if you make a change to a Gradle file and you're maybe adding a dependency, I like to add that dependency, commit that change. All right, I made this change. I know it's small and pedantic, but it helps keep me and keep my log inside of Git fairly clean so I can see what's changing. I don't have these huge monolith check-ins where I'm like, wow, I don't know what broke. This also helps if you need to also bisect something in Git. So let's say you all of a sudden you implement a feature and then 10 days later you realize, oh no, we broke something and there's been 300 commits since then. You don't know what it was. Well, you know that, hey, 2 weeks ago it worked then. Okay, you can use git bisect to help you determine which commit broke your application. And if you're using small commits, it's easier to find. But if you have something that's this huge monolith change with 10,000 changes in it, well, it's going to be even hard to determine what broke in there. But if you have small little incremental changes, you can say, hey, I added these 2 or 3 files here. All right, it's somewhere in here that it broke. Let me figure it out. Now, another big one in regards to that, if something breaking, do not check in broken code. So if you have something that is broken, it doesn't compile, the feature's broken, do not check it in. The build server is a source of truth. It's going to catch our errors, of course, if we put them in there, but if you know it's broken, don't check it in. Try not to check in untested code too. This is, again, very hard in Android, but if you can, try not to test in untested code. It happens to the best of us, but just the best you can. Furthermore, in regards to things that are broken, if you do check in something that is broken, or you break a test or something like that, and the build fails, according to one of those things that had just happened, do not check in any more code into the repository because now the state of the build is broken. That's the source of truth, saying, hey, this is not working, it's broken. Don't continue to check stuff in right now. So what you should do at that point is fix what's broken, then check your code in. It's also if you're on a team, you want to be very cognizant of the people on your team because they don't want to pull your code down. It breaks their local environments. And now you have 3 developers, 4, 5, 10, 20 that are all down right now. They are not producing code. They're not producing value for the business. They are now costing the business money because of a broken build. And so this is kind of where the build server kind of helps prevent that. And if you haven't had a build server, I'm sure you've run into it before where you pulled the code down and then boom, blows up and you talk to the developer that sits next to you like, hey man, the code's broken, or hey, what's going on? And they're like, oh, it works on my machine. And then you realize they installed some weird dependency and had to install inside their path and a whole mess of stuff. The build server will catch all that for you. And it will let you know, hey, as soon as he checks that code in, the build will fail saying, hey, I can't find this binary over here. And then he's going to realize, oh yeah, I got to install that on the build server. I need to let the rest of the team know to install this dependency on their machine so we can use this new feature I implemented or whatever. So now you're going to develop your own rituals and policies on your teams. as the days progress and you start using a continuous integration environment. But always kind of act cohesively as a team, saying, hey, here are here's the kind of rules that we live by. And some of the ones before are just really kind of not law of the land, but just good ones to follow in general. Now, I do have a few tips for you if you're setting up a continuous integration server. The first thing is a lot of people don't know when to add their application to the continuous integration server. You may be spiking out a new feature or spiking out a new test app for your company, and you kind of get it working. It's like maybe an MVP, a model view, not a model view presenter. It's a minimum viable product for your company. At that point, you show it to your boss, and before you know, it's kind of turned into this thing that everybody's working on. As soon as you realize it's in one of those situations, you need to get it into a continuous integration environment as soon as possible. Secondly, a lot of people say, well, this sounds great, Donn. I love the idea. I could see the value in it. I just don't have time to set this up. I can understand that too. I've been in those situations. Thankfully, now there's a lot of cloud-hosted solutions, which I'll talk about in a moment. You use one of those cloud-hosted solutions. Some of them are free. Some of them you have to pay a little bit of money for. Even if you got to pay a little bit of money, it's going to save you a tremendous amount of time from setting it up yourself. Even if it's only for a couple of months, you can tell your boss, hey, look, maybe we got to spend $100 or $200 for the next couple of months. Then after that, once we're up and running, we can bring it in-house, but at least gets us going and gets us productive. 3, make sure you set up integrations to your team in communication channels like Slack or HipChat or whatever. So when the build fails, the communication channels get updated. Say, hey, looks like the build failed. Everyone gets notified. This is key if your team is remote too, or even if they're kind of partially remote or even working in different offices and you have remote developers or even overseas developers. Very important. Number 4, make it a rule that if you break the build, it is your immediate responsibility to fix it. That means drop everything that you're doing and fix the build immediately, because now the source of truth, the build server, is saying there's something wrong. At that point, you need to drop what you're doing, fix the build, get it back in working order so everyone else can continue contributing to the business through the code that they're writing. And number 5, try to get some buy-in from your manager. Now, a lot of times this can't happen because the manager says, we don't have time. We can't do that right now. We need to do this. If that's the case, go grassroots. Do it yourself. Come in early. Do it on the weekend. Stay late. Set up a build environment, because what's going to happen is you're going to find that it saves you 10x, 100x the amount of time that it would as if you didn't have it. So now we're up a couple of concerns that people have right here. One of them is, I don't have any tests. Why should I even do this? Well, first things first, you may just be compiling your code and outputting a binary. That's a huge benefit in itself, because now your boss can go get the binary without bugging you, or your client can go get the binary. Secondly, if you add, or your team member adds some weird dependency that you need to have installed on the machine for it to build properly, you're going to get notified as soon as the build server fails because you forgot to update the build server. Again, this is a source of truth. It's an independent machine that no one is touching. It's just running up in the cloud somewhere, or maybe on a Mac Mini somewhere in your office or something like that. Now, furthermore, a lot of people get into these weird situations where, like, I can't even write tests for this because my code base is so legacy. It's just this huge hodgepodge of spaghetti mess. What do I do? Now, the best thing I can recommend you do is actually immediately go buy the physical copy, not digital. Go buy the physical copy of Michael Feathers' Working Effectively with Legacy Code book. It's a seminal book in the industry, and I still have a copy on my desk to this day that I constantly refer to. And the reason why is just the way he breaks things down for you is just simple. Anytime you're working with code that doesn't have tests, it's considered legacy code as one of his principles. But furthermore, the titles of the chapters are what really drew me to this book, and then I ended up reading it all, and it's great. And here's some sample title chapters of that. Chapter is, I need to make a change, but I don't know what tests to write. Another chapter title is, Dependencies on Libraries Are Killing Me. And another chapter title is, I don't have much time, and I have to change it. I'm sure we've all been there. Another one that resonated with me is, It takes forever to make a change. I've been in this situation many times. And finally, another one is, I'm changing the same code all over the place. And the one actually that sticks in my head that I don't have written down here, but I remember it, so kind of going off the cuff here, is I need to change a monster method and I can't write tests for it. I'm sure we've all been in that type of situation. So great book. Again, it's Michael Feathers, Working Effectively with Legacy Code. We'll add that to the show notes. And finally, if you're co-located, have some fun with this. Use a build failure trophy. Grab like a pink unicorn or something like that, or a Gumby action figure, something silly. And if one of your team members breaks the build, go over and put that trophy on their desk. They get to hold that trophy until the next person breaks the build. And it's kind of just this fun little team building thing. If you're in a remote team, everyone's, not in the same building and you're all over the place, set up a different channel, or just integrate it directly into your team channel saying, hey, it looks like Donn broke the build, and have HuBot or one of the Slack bots built to automatically post an image that says, hey, Donn broke the build. Just something quick and fun to help build the team a little bit more. Now, in regards to continuous integration, again, we're pushing code up, it's getting built, etc. If you're working in web, you may also encounter continuous in deployment, where the build succeeds, everything's good, and automatically the build gets deployed to production. Now, this is kind of risky because you need to make sure you have tests. This is key. You want to make sure you didn't break anything. A lot of companies do this, hundreds of times a day. One big one is actually GitHub. They do it a lot. Etsy is another one. Another one is also RunScope. There are hundreds and hundreds of companies that do this every single day and just automatically deploy the changes. They will deploy 50, 60, 70 times a day. So continuous deployment is something you can set up inside of your build script. For Android, they've recently released the API where you can talk to Google Play and kind of manage your releases that way. My advice is still kind of manage that a little bit manual. I wouldn't release every single day or multiple times a day. Simply, and I don't even know if that's possible, but simply because you don't want to bother your users with, hey, this app's updated, this app's updating, this app's updating over and over and over. Eventually, the user's just going to get frustrated and say, I'm done with this app. I don't use it that much. I'm tired of it updating my phone and killing my bandwidth and killing everything and so forth. So I usually aim for at most once a week, maybe twice a month or once a month if it's your application's making big changes. Now, in regards to continuous integration servers, you don't have to use a particular kind. I'm not married to anything. The most common in the industry that I see at this time is Jenkins. The cloud solution for that is called CloudBees, and you go to cloudbees.com. You can also use something from JetBrains, which are the company that's responsible for Android Studio. You can use TeamCity. There's other cloud providers like CircleCI, which I have a video on caster.io, how to set up a free build on CircleCI. There's ship.io. And of course, there's always Travis CI, which is free for open source projects. Or you can use travisci.com, which is for basically private repositories and so forth. Now, some of them are free, some of them are pay. If you download Jenkins, you can download it as open source, or you can use the cloud solution through CloudBees. Again, some are free, some are pay. If you host it yourself, you do have to worry about setting up your server, installing Jenkins, making sure your ports are open, blah, blah, blah. But it does give you the most freedom. You can create the most builds and kind of customize it to your heart's content. Now, let's talk a little bit about collective code ownership. So this is kind of related to continuous integration. And this is an extreme programming paradigm that basically says collective code ownership encourages everyone to contribute new ideas to all segments of the project. Any developer can change any line of code and add functionality, fix bugs, improve designs, or refactor. No person becomes the bottleneck for changes. Now, initially, this is kind of hard to understand because a lot of companies have these ivory tower architects at the top saying, you will do this and you're only going to work on the billing component. And you're only going to work on the customer service. And that's, if your business is siloed like that, then that may be the way that it is. But even if you are in that silo, there's still probably parts of the code that you may not touch because another developer is more familiar with it. But collective code ownership says, hey, we should be able to all work on this same code base together. And what makes that possible is actually unit tests, because unit tests are little islands of code. And these are basically little confidence builders saying, let's say I knew that my entire application was 100% code coverage, meaning that every single line of code had some type of test executing it. I would feel very confident, even though I'm not even familiar with the system, to go in and change something. It's all right, well, the application needs to do this now. And then I could run my test and say, all right, well, hopefully, let's see if I broke anything. All of a sudden, maybe 2 tests fail. Like, oh, I didn't think about those 2 edge cases on the side there. Now, that's what these unit tests do. They facilitate the ability to incorporate collective code ownership. So if you are interested in this, and which I hope everyone is to get yourself into a model of collective code ownership. Create enough unit tests where it kind of creates these huge, large islands of confidence where the developers on your team can all sit together or independently and work on features that they may not normally touch all the time. Because let's be honest, sometimes you get on with a feature, you don't touch it for 4 or 5 months, you're on to something different. All of a sudden, some bug pops up. You're working on something important for the CEO. The junior developer comes in. He needs something to do. Well, he can come in and fix this bug. But before, maybe if he wasn't that familiar with it, and because there's no unit test, you would have to kind of stop what you're doing, maybe work late, work the weekends to fix that issue. We've all kind of been there. Again, so this is facilitated by writing unit tests. If you can write enough unit tests to get everything covered, then we should have enough of a confidence building system through these unit tests that we can have this wholesome collective code ownership. So meaning that anyone in your in your development organization can change any method of any class and release it to the repository, and it should still pass tests. Now, they still need to write the test for the new feature they've built, and so forth. And in the end, what ends up happening is collective code ownership means that your organization is a lot more reliable than just putting a single person in charge of watching these specific classes. Like, hey, you're not allowed to touch the dependency injection stuff because it's, only this, or you're not allowed to touch the billing components because of this. So it kind of frees you from those shackles of having a particular mindset inside of your organization. So let's review what we covered real quick. We have continuous integration, where we're going to push code up to a central repository like GitHub. The continuous integration server is going to pull it down. It's going to build it. It's our source of truth. We're going to be able to get artifacts off of that. We're going to be able to make sure that the build succeeds. We're going to make sure we run tests up there. Everyone's going to be notified if something goes wrong. If the build fails, everybody gets an email saying, hey, this commit that Donn did broke the build. So I know that I'm the one that needs to go fix the build. It's my immediate responsibility. Drop everything that I'm doing, go fix the build. If you do web stuff, you do have continuous deployment. You can set up to automatically deploy stuff. If your build is successful, we really don't do that much in Android that I've seen, but there are some companies that do it. So it's worth mentioning. And finally, collective code ownership. Let's get these unit tests in place. That's really what this is saying. Let's get as much unit testing in place so we can feel confident as an organization, as developers move into our organization, and as we grow, that anybody in our team can work inside of any part of our code base. I hope this fragment has helped. Please let us know. Again, you can reach out to us at FragmentedCast, or reach out to myself or through Kaushik through Twitter. Thanks again. We'll see you next time.